So today on the bench we have the TOMLOV 7-inch digital microscope, and this is the DM201M. Ooh, what's the M? So we've done the 201 before, but this one has a difference. And what is it? If you hadn't spotted it already, it's the multimeter leads. So how cool is that? This is what the leads look like. So cool. We'll look at these more a little later. Pretty much everything else is identical. Well, I say that. The remote has definitely been upgraded. It looks very nice. The buttons feel really good on the remote. A lot of this is very similar. We got our two USB cables, our HDMI cable included. I've always appreciated that about TOMLOV. The power adapter, the light barrier ring. Here's our base with our new warning about not going over 36 volts. Our light intensity control, our USB-C to the base, and also our multimeter input jack. Let's go ahead and put the base and stand together. And like the 201, it's got the really nice stand that gives us plenty of available work height. I really like that. Go ahead and put our light barrier ring on here. Before we install it, makes it a little easier. We'll go ahead and hook up our USB-C cables. Yeah, let's grab the longer one first, and we'll hook it up straight to the microscope display itself. Sorry, I got this off camera here, but I'm just plugging it up to the USB-C. So into the microscope display and out from the display to the base. That way our microscope is always plugged in and powered up first. We'll plug it up to our adapter. Go ahead and plug up our leads. Just like so. Awesome. We'll plug up our power adapter, and this should charge as well as power the microscope. By the way, this is the new manual, but since this is version 1.0 and this is a first look, some things are subject to change, so I'm not going to share much information with it at this time. But it does look like they're going to do a DM202M as well, which is neat. I'm going to go ahead and power on the microscope. And there's our on-screen display for the multimeter. How about that? Here's our look from overhead. I do like how sharp the tips are. They're long and very sharp, so they're going to be nice on the board when we're probing. So we're in ohms mode, and a little bit of auto range time there, but it's still quick and zeroes out very well. I like that. Let's use our clips. These have clips a lot like oscilloscope clips, but these are attached to the same point on the lead tip itself, so it can be used in place of the tip for grounding or something of that nature while you're testing. So that's neat. We can take those off easily as well. I'm going to leave them on for now while we're testing, but a quick press of the button on either lead takes us through the different functions of the meter. A long press, by the way, will do a screenshot. I'm going to bring over a battery. That's a 21700 that I have fully charged. And yep, 4.12 volts. Perfect. That's exactly what it's charged to. Awesome. I probably won't go a whole lot higher with voltage while I'm under the microscope typically, but it's good to have the capability if you need it. Just don't go above 36 volts. Alright, so now let's see how it connects up to the PC. It's probably the same as the 201 and 202, but I'm going to hook it up to the computer. The MSDC mode, of course, is for the SD card for your device storage. If you want to go to the PC camera, we go to UVC mode. And once we select that, we go to the PC and we just go to the camera app. And mine's connected just like that. You might have to select which camera you have selected, but this is the only one I had connected at the moment. So if I hit record, I'll adjust this a little bit and I'll show you on the screen here what I'm recording. So this is what it looks like. as I'm recording on the PC itself. But I do realize the image is a little bit blurry on the left side, so yeah, I need to adjust this light. And the image is tilted a little bit, so I'm going to get my board holder from Northridge Fix. Pretty nice board holder if you've never seen it. It'll hold the board level, so that way it won't be a little bit out of focus on the left side the way I had it tilting. So now if you see, I have it on my monitor, and I do have the on-screen display. And how we're doing that is through this mini HDMI. The cable they send with it is going out to my monitor. So that is cool that the HDMI does output to the big screen. You can see it there. And we can actually have it on the monitor for us with the on-screen display, which is really neat. We'll do diode mode. Diode mode's handy. It doesn't beep, but it does show very well on the display. Let's grab a couple to check here. Let's see, D4. This should be reverse bias, so definitely don't have a short there. Let's turn it around to forward bias. We're looking for half a volt or so on these diodes. Yep, 0.575, good. Let's check. This was actually a Zener, but let's check it. 2.16, so no short. Let's forward bias. Yep, 0.56, good deal. So let's go through and change the mode here or function. We'll go to ohms, and this is a 01B, 1K. These are the EIA96 standard, by the way, so a little bit different marking here, but yep, 1K dead on. We got another one, should be a 1K as well. Yep, 1K. This is a 100, that's not 100, that is 10 and 00, so that's 10 ohms. Perfect. We have another 01B, 1K. Spot on. We have a 474, and that's going to be 47 and 40, so 470K. Perfect. You see there, 47 and then 4 zeros. We have a 01C, which is going to be 10K ohms. If I can get on there. This board does have that conformal code, and it's been a little bit of a booger, but these probes are sharp. 10K, there we go. So that worked out great. Let's go through a few more functions here. From ohms, we'll go to volts DC, then millivolts DC. We have volts AC, millivolts AC, then our diode check, our continuity, and the continuity works very well. It has a very good responsive beep to it. I really like that a lot. That'll be very handy. Of course, we have capacitance mode. I didn't have the best luck testing on this board with the capacitance, but I'm going to bring over my little capacitance substitution box, and we'll go through some of the capacitance values on this box. I'm going to start off with 0.1 microfarad or 100 nano, then 68 nano, 56 nano, 47 nano, 33 nano, 22 nano, 6.8, 5.6, 4.7, and back. So there we go. That worked out pretty well, checking it out of circuit anyway. I'm most likely going to use diode test continuity and resistance the most. So as far as the way to capture video for you to see with the on-screen display, I have a ClearClick HDMI video capture device. So one thing I want to show here is this HDMI going to my capture device and seeing if I can record that way. So I use this for recording sometimes, and it's fairly new to me, so I still don't know everything about it, but I've recorded a few videos with it so far using my overhead camera going straight into it. So if I plug it into here and then go from here to the monitor, I'm showing 720p, which is I don't know exactly why, and I don't see my on-screen display. Let me check my HDMI connection. Yep, it shows up on a microscope. Back on. Okay, there's a multimeter. So it did show up. So it may be a problem with my HDMI connector. If I have it here, then I should be able to record on this clear click capture device. So I must have had a bad connection there. We'll see how it goes. All right, if I hit record on my remote for the clear click, it shows that I am recording now. So let me get the board set up in a good spot here so you can see on my monitor here what it looks like. And I'll get my probes ready. And I'm going to go back to resistance mode so you can see that again. We've already done it with you just seeing my monitor. And now I'll let you see how it records on HDMI. So a very similar check as earlier. 01C, which is 10K. Let's go over to 01C again. Yeah, that conformal coating's on there. Let's dig a little deeper. Got it. All right, so this is a 305, which is really a 3 meg, 30 and 50. And I am getting a good connection here, but I'm going across the transistor. So the transistor is less impedance than 3 meg, so that should be fine. So let's try this 511. Now that's 5, 1, and 10. So really 510, but it almost shows it exactly 511, but really a 510 ohm. Let's see what else. Another 01B, which is of course 1K. 1K on the money. Another 01C, 10K. Good. And a 01E, which if you can imagine, it's going to be 1 meg. Yep, dead on it. So awesome. So let's look at the response time as I move my meter lead. You can see in real time on the bottom and my recording image up top. And there is truly very little delay time because I'm going HDMI out through my clear click and recording and then back out to my monitor. So that's pretty impressive, really. One quick check I'll do is frequency. I'm just going to throw a 100 kilohertz signal out. And as you can see here, it shows up perfectly. Now that's a square wave. I'm going to do a sine wave. Yep, still good. Now triangle wave. Yep, still good. No triangle wave. Awesome. I want to take time here to show us taking the alligator clips off of the meter leads. They pop off just like so, just like oscilloscope probes. Difference is these are connected straight to the probe tips itself. Same signal, same connection point. Very handy and very easy to take off. So in continuity mode, it should be anything less than 50 ohms. So here's a 47 ohm resistor, and yep, got it. So this will be very handy probing around. This board just happens to have a push button here, so I'll show you how good that works. It's a tiny push button, but there we go. We know it works well. It'll be great checking push buttons and things of that nature. And we look here, 5 volts at 0.99 amps. Our adapter is rated for 1 amp, so it's definitely okay for running the microscope. But if we look here, you do catch it at say 1.5 to 1.6 amps. And the reason being is sometimes this microscope needs to charge the battery. If it's charging the battery and running the microscope at the same time, the adapter does get overpowered. And I appreciate some viewers sharing this with me, because I always just hook it up to my 2 amp to 5 amp supply that I have readily available on my bench, and I did not catch this. So when I did share this with TOMLOV, they said they would upgrade this to a 2 amp, so this shouldn't be a problem in the future. But the reason I'm sharing this is because everybody's feedback does make a difference, and a company like TOMLOV, they are listening to us, so it's a win-win for everybody. So I really appreciate the viewers that did mention, hey, when I got my microscope, the adapter was getting warm. Matter of fact, I was called out for not testing it because I just plugged it straight up to my 5 amp supply that I had readily available. But true enough, it's always good to test things to the full extent, and it's always good that everybody shares information that they find. I do want to thank TOMLOV for sending out this new microscope for us to have a first look at, as well as listen to the feedback to make things better, including the power adapter, and there's been a few other things that I've mentioned to them and communicated to them as well, including eventually trying to get the on-screen display to work with the USB PC connectivity. But you are going to see this microscope being used a lot more on my bench in repairs. Thank you for watching the video today. I hope you found it helpful. I'll have a link down in the video description of the microscope, and they are giving us a 1-month discount code for the microscope that might be handy if anybody's interested in it, and we appreciate them doing that as well. So thanks so much for watching, and God bless.